Okay, so let's get started. Just to let you know, I've just started the recording. Okay. Uh, so let's start with Spark. So this is the website to go to, right? So you have a documentation page here. You can actually look at the documentation. The Let's start with Spark programming guide. I also have a couple of slides that I actually used for one of my presentations a few months earlier. So we can actually just go over the slides, just to get an understanding of what Spark is. So Spark is a general purpose in-memory distributed computing programming model, right? So in Spark, the way you actually model your Spark program and run it is by doing these things. Like you will set up a driver function that executes parallel operations on a cluster. And there are many modes for having this driver function. You can have this driver function be a part of the processes on the cluster, or you could actually have that as an external program running outside of the cluster with a connection to the cluster. So one of them is called cluster mode. The first one is called cluster mode, and the second is client mode. So that's one way how you define your driver function. I mean, driver process. So it's like think of that as your main program in Java or C++ or any of these languages that actually drives the whole program. And the basic data structure for Spark applications is called an RDD. RDD stands for Resilient Distributed Data Sets. And what that is it's a collection of elements that gets distributed across a cluster. So the set of elements that you want to process in parallel across a cluster, you can make that into a collection. Think of that as an array or a list where pieces of the list are spread across the cluster. So you have so let's say it's a set of objects that you have. So you make an RDD of that type of objects, and what's going to be worked upon are fragments of that list of objects across the cluster. So the first RDD that you start with in a program can be created in many ways, and you can start that from a collection that you actually define in your driver program from HDFS, or a local file system, or a network file system. So if it is HDFS, the pieces of data that form the RDD will actually be sourced from the local machines where, the nearest machines from where your Spark executors run. And if it is a local file system, I think this will work only if you have a one node cluster. and in a network file system, if it is if the data source for this RDD is on the network file system, you can you need to have connectivity to that common location on the network file system from all the nodes that run your Spark processes. Other ways that I have not mentioned here in the slides is from databases, data stores like Cassandra or MongoDB and things like that. So you can actually define your collections as a result of a query that goes out to these databases, and you can actually bring the data set from there, and you can make an RDD out of that. And so the last point here that says RDD said as pickle during computation can be loaded back as well. You know what it means is, you know, during a set of processes or transformations that you do on an RDD, at some point, you know, you can actually save a version of that in the process and then use it for further you know, computations. So I'll make that clear. You know, we'll have that clear as we see actually a few examples. And RDD can be subject to two kinds of operations. One is transformation. The other is actions. So transformations actually give you another RDD when you start with an RDD. So what it means is you start with an RDD and you define how your map. I mean, you define something called a map operation, or there are many types of these map operations. So what you do is you start with an RDD and apply a map on that, and then get another RDD. That's a transformation. And another type of operation that you do is called actions. Action could be, you know, an aggregation of certain things in an RDD and things like that. For example, so let's say you have a bunch of key value pairs as your RDD, and if you want to do if you want to actually group by keys, like how you have the group by operation on SQL data sets. So if you want to group by key and then aggregate the value, like a sum or average or things like that, so that would be an action. Or if you want to save a whole RDD to HDFS, that will be an action. So as I said, transformations results in other RDDs. And so there are other things, like all transformations are lazy evaluations. You know, so lazy evaluation is, you know, these, when you actually apply these transformations, you know, nothing happens on the cluster. So your Spark framework just records what transformation you're wanting to do, but then the actual actions happen when you actually apply an action on the RDD. So this way, you know, it actually packs all the transformations between two actions, and then you know, it fires all of them at once. So that actually makes for very efficient running of the code. And actions are, as I said, aggregation functions. And RDDs automatically recover from node failures. So because you actually have a complete map of what process is happening, you know, it's called a directed acyclic graph. So what it, well, any program that you write in Spark, it is represented as an acyclic graph, a directed acyclic graph. And so that's like a blueprint for your application. And let us say you have a 10 node cluster, and while in the middle of your process, one of the node just disappears from the network, or one of the node crashes, then RDDs automatically recover from that. So another executor will be spun up somewhere in the cluster, depending on how the resources are managed, and then the data that it lost will be recovered from an alternate replica, if it is HDFS, and it'll try to get back the data. And there are two other features that are handy. One is called broadcast variables. Broadcast variables is the idea of that is, let's say you want a read-only copy of a small amount of data that you need in the processing on all the nodes on the cluster. You can actually broadcast that data, and so that piece of data will be available on all the nodes in the cluster. And accumulators is another thing. Accumulators is, if you want to have, let us say, the progress of your processing on an RDD. If you actually have a variable that actually just counts the progress, and like as you know, all the action happens on the cluster, right? There are many nodes, and so let us say you want to count the number of objects that are processed. If you have 20 nodes, and if you have spun up 20 different executors for Spark, on each of the nodes there will be a count happening as to how many objects were processed. And if each one of them update a driver process on the progress, it could be that one overwrites the other's local version of what the status is. So you don't really get a count. So accumulators is a way to track that. So this is like a global variable for a distributed setup like this. So well, we can see, eventually we can see, but not today, I think. We will see examples of all of these. But what we'll see today is just a rudimentary example of an RDD, how we could make that and things like that. Okay. So,
Kumar, I have a question here, Kumar.
What RDD is? Sorry, somebody?
Yeah, Kumar, this is Sahir Kumar.
Yeah.
So you said in the slide that this RDD will automatically recover the data which is lost, right?
Right.
In one of the point.
Yeah.
RDD automatically recovers. So for example, in my cluster, if I have 5 nodes or 10 nodes, my node number 5 is failure.
Yeah.
So how do it recovers? It needs additional node in the same cluster?
Well, so I mean, this, if you actually have set up the data source as, let's say, the data source is HDFS, and when you ran the program, let us say you have configured this to actually have so let's say 5 executors, right, or 10 executors. So you have a 10 node cluster, you have 10 executors, one running on each node, and your 5th node failed. And so when the 5th node came up, when the 5th executor came up in the first place, it probably would have acquired its piece of the data set from the local node on HDFS. So if that fails, the Spark framework will instantiate another executor on a different node. Maybe it can pick up a node like a 6th or 7th node, and then it will start another executor process, and the executor process will go back to a replica of the blocks that were read on HDFS, and they'll source it from another location on HDFS. So all that it should do is, it should keep track of the blocks that were lost, right? So once it gets that, it can, it has to make a call to the name node to actually get the files and the respective blocks, and then it can reconstruct basically the whole thing.
Okay.
Does that make sense?
Yeah. So I have one more question, Kumar. Sorry. In the website, right, Spark official website, I see it's 100 times faster than Hadoop.
Yeah.
Using the DAG technology, DAG tag.
Okay. So you mean
Can you go to homepage?
okay. So let's see. Yeah.
Yeah, you see, Apache Spark has an advanced DAG execution engine. What is this DAG?
Well, a DAG is what I said. Directed acyclic graphs.
Okay.
So I mean, you can actually think of the Spark execution as a directed acyclic graph. So what it means is the actual process that you run. So maybe I should just write it somewhere. I'll let me see. Let me see if I can use a tool like this to write it. Okay. So let us say, you have a process that goes like this, read. So let's say your process is like this: read a file, uh, read file from HDFS, read file to from HDFS, and then you do a join of these two, right? So that's a join. So that's a read. It's difficult to write with the mouse. So this is a read. So this is another read. And once you have those two RDDs, you can do a join of the RDDs, and you may do a map, and you may do an action, right? So that's a DAG. And and this, like, if you are reading it, you're actually looking at pieces of data here, pieces of data here, and the join may need a shuffle between them. You know what I mean, right? Like, think of this as this. This is a list, right? This is an RDD, that's a list. So when you do a read, this is an RDD, that is a list. And so let us say you actually join this RDD by let us say key. So this list has to be kind of key value pairs. So this list has to be key value pairs. And so let us say you're joining these two by keys. So this is similar to a join that you see on an SQL data set, right? So if you have two tables, you can actually join them by keys, right? You can join them by one of the uh, columns and things like that. So that you think of that column as a key. So this essentially represents a DAG, and Executing this is basically running your program. So it has an advanced DAG execution engine that supports acyclic data flow and memory computing. So what happens is this. Let us say that when this read happened, so let's say you had different uh, pieces of this data sitting on the cluster, and you have different pieces here again, things like that. And when you join, the key that you get in one of these that is joined with data here, they may not reside on the same node, right? So data gets shuffled when this happens. So this is the kind of action. And so anything that you have earlier than this. So let us say you have read, and let us say you have some maps here. Let us say you have some maps and things like that. Until an action happens, these reads and the maps and all these things will go parallel, right? I mean, there may not be any activity on the cluster. Something called lazy action is actually implied here. So only when when an action happens, all of these things will kick in, right? And so that actually uh, accounts for very efficient execution. So to answer your question, a DAG is essentially a graph like this that will represent your application, your process. So here, unlike a UI process or something, here we are running a process that runs from start to finish, right? It's actually a batch process. So that's what we're looking at in this case. Does that make sense? Sorry.
Yeah, Kumar. Thank you.
Yeah. Okay. So let's actually do this. This is what I plan to do today. I have some data on Google Cloud. I just put that on the Google storage. I'll spin up a Hadoop cluster. I'll create a data, a folder by names data, and then I'll copy some files from there, from the local to um, this directory on the Hadoop cluster, and I will maybe I should use the second part of this. So I will create an RDD and run some maps, and then run an action. So you will have a map process and action and things like that. Okay, so let's do that. So this is my Google Cloud Platform console. Um, well, I will start a cluster by one of these packaged applications. So I'll use dataproc. Dataproc is the uh, well, is the application that you have on this console that will give you a cluster. Okay. So we'll create a cluster. So let's call it test 01, and I'll choose. So this is the region. It's a Google data centers region, and so within US East 1, you have. I just chose this. I'm assuming that this is the closest to us. So I don't need a cluster of this size. So I will just use a master node. Well, let's use that. So here we have a choice. We can make this a cluster that's a single node, or a multi-node cluster. So let's choose a multi-node cluster, and we don't need this much of disk space on each. So let's say we have 25 gig on the master. We don't even need that for our purpose. And I'll spin up a similar machine with two nodes, and let's say 25. So that will give me 12 gig of yarn memory. Okay, so I'll just create the cluster.
Kumar, meanwhile it is loading. What is that ARN memory?
What is what?
ARN. YARN, ARN.
Oh, yarn is this is a Hadoop cluster that I'm starting, right? So yarn is the OS counterpart of a cluster. Like, think of that as the total amount of memory available to applications. So this is sum of all the memory that you have on the cluster for running your applications. So we spun up two nodes, or two slave nodes, right? I mean, one master and two slaves, and each of the slaves had 7.5 gig memory, and there were two of them. And so assume that 6 gig out of each of those is available for computing. So that's why you had 12 gig of yarn memory.
So is it like a RAM memory, right?
Yeah, it's the RAM available. It's the sum of RAM available on all the nodes in the cluster.
Okay.
Okay. Sometimes this doesn't refresh quickly. Maybe it's done already.
So, hi Kumar, Harish here. Good morning.
Hi Harish.
It's a very general question. Generally, if you want to use this platform and if you want to run this big data clusters and all, what is the system configuration we should have?
Well, I'm running this on the cloud, right? So as long as you have a browser that works and you're connected to internet, that's all you need. So the actual system is running on the cloud.
Okay.
So
Our
this
physical
cluster, I'm
machine,
bringing up this cluster on the cloud.
so our physical machine configuration doesn't matter anything.
Yeah, your own machine configuration doesn't matter, because I'm not running this Hadoop cluster on my local machine, on my local laptop.
Right. So to get access for this, we need to pay, or is it a free source something?
Well, on Google, if you sign up, you get about $300 of credit, 300 USD of credit, and you can spread that use for 1 year. And for purposes like this, if you spin something up like this and then shut it down right after maybe half an hour or 1 hour, you will be able to use that for a very long time, actually.
Okay.
So, I mean, for learning purposes, if you just use it even after this quota expires, right?
Mhm.
Uh, for learning purposes, if you spend $10 or $15, that should be more than enough per month.
Right.
So we spun up a cluster called test01, and we chose to have one master and two slaves. So as you can see, you have a master and two worker nodes, W0 and W1, and you can actually log on to the master. So you can start an SSH session into that. So let me do that. So this gives you a way to connect to the master, to the cluster. In a typical Hadoop cluster, you'll set up something called an edge node. It's a part of the cluster, but you'll use that only as an interface between the outside world and the cluster. But in this case, you can directly go onto the master. This is where uh, your name node would run. So okay, let's see here. You see, we spoke about name node in the last session, right? Last week. So this is the process that's the name node. The name node basically keeps track of your HDFS blocks and stuff like that. Okay, so let's actually do this. I also want to show you the set of files I have. We'll just use one of those files for processing. Uh, So this Google Cloud Platform, what I use to bring up the Hadoop cluster is among these applications, I use an application called Dataproc, and you have a lot of other things here that you can explore. Uh, okay, so there's another thing that you will use very frequently. This is Google Storage. So I placed a few files last night on this. Um, in this folder, data aggregation. So we will not use one of these large files. I don't want to run. So let's start with something smaller. And I think the format of this file is also not suitable for the code that I have. So let me use this file today. But we can actually copy over all of these into that uh, local file system on the name node. So before I do that, let me spin up one more secure shell. So this is like your Google Drive. So in this case, it's not exactly like Google Drive, but the functionality is similar. So what I'll do is I'll say gs util GSUtil, by the way, is the utility that you use to actually do a lot of things. So one of them is, you can actually start from, uh, uh, well, a lot of things with the storage. GS is Google Storage, Google Storage Util, that's what this is. So you can move files into storage and copy them from storage, etc. That's what this is for. GS. So this is the folder that I have, data aggregation, and I'm copying all those files to this local machine. On, like, I just picked one machine, right? So this is the machine I'm on. But of the three machines that we spun up, test01M is the master node, and I've just logged on to that Linux machine that represents that master node, and I'm copying the files from the Google storage into this locally. So yeah, I'm copying way more than what I need, but this is just okay. So let me expand this window a little bit. So let's take a look at this data. Okay, so the data here is, think of this as a business date. Think of that as some deal information. It could be a particular trade ID or something, that that's in the portfolio of, let's say, some financial institution. And let's say that's the product ID, and that's the portfolio number, and this is something called a scenario. I mean, let's not worry about what these things are. And I have a number here that represents a profit or a loss in scenario 0, profit or a loss in scenario 1, and things like that. So let's not worry about the meanings of these. We can talk about this in another session. So what you have is data of this kind, and as you scroll more, you have other product IDs, different portfolios, and people focus on these two columns here. Portfolio O3, well, the column that represents the portfolio, and the column that represents this last number. Okay. So let's see how we could read. Before we actually do anything with this, I need to put this on a. Right now, this is on my local machine. That means, so this file is only on my on one node among those three nodes, right? It's not on HDFS. If it is on HDFS, only pieces of that will be available on any of these nodes. So the first thing I need to do is to copy this to HDFS. So I'll copy just one of these files to HDFS. So before I do that, I need to create a directory on HDFS and then copy this file over. So before I create a directory, let me see, what I have on the HDFS file system. Hadoop FS. So the Hadoop FS is Hadoop file shell. So this is like your Linux ls command, list the files. List the files at root directory. Okay, so you have two folders, and I'll create another folder, mkdir So this is your usual Linux command. It looks like that, and it's a you have to provide the full path for whatever you do here. So create a folder from the root called data. That's what this does. Okay. So if I run the Hadoop FS minus ls, I should see the new folder. So this data directory is on HDFS. So that means it's a part of the cluster. And so let's copy this file over to this folder. So you do Hadoop FS.
So, Kumar, this data folder is created on master node or the name nodes? No?
Well, this data folder is HDFS, right? That means it's a distributed file system. So you'll only see if you have. I mean, you will see this data. You'll not be able to list this folder on individual nodes, but you will be this represents a folder across the cluster.
Okay. Where it is actually created physically?
Physically, the name will only be in the name node.
Okay.
Right, name node represents a data structure, right, of the file names, the permissions, well, these inode permissions, right,
Right.
inode data that represents the permissions, and things like that. And when you put a file like this, like what I'm doing now, I'm saying copy from local. That means copy from this local file system to which is the file to be copied. This is the file to be copied, and copy it to data folder. When I do this, this file will get chopped into blocks if it is a very large file. So I mean, in this case, the file is what, like 5 MB here, and 5 MB is not much. It's a small file, so there's only one block. But then that block will be replicated. The default duplication count is 3 times. So you'll actually see 3 pieces of this, three replicated blocks on one on each node. Well, I think one of them probably will contain 2, since we only two data nodes, right? We have only 2 workers. So 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 we are actually talking about blocks. You will not be able to go to each node there and look for a directory called /data. That's not going to happen, right? So on the name node, the name node will maintain information about this file which sits in the data directory, and it will keep track of the blocks that comprise of this file. So does that answer your question? I mean, like,
Yes, Kumar. Yeah.
yeah. Okay, so let's do that. So now the file is copied over to HDFS. So if I say Hadoop FS minus ls /data, I should be able to see my file there. So when I say you're seeing the file, this file is again not in the local system. So the name node actually, it's the name node that's giving you the information. It's saying that you have an HDFS file that looks like this. Okay, so that's, we have put the file there, and now we are ready to actually start your Spark session. So you can actually interact with the cluster using Spark in several ways. You can choose your language to be Python or Scala or R. So any of these languages would be fine. So based on what you would want to do, you will either say, if you're looking for Scala, again, you can do this in many ways. You can start an IntelliJ IDE, write your Scala program, compile that, make that into a jar file, push the jar file to the cluster and run it. That's one way. Another way is you can do this interactively, like how you do it with a Python interpreter. You can actually run code line by line that gets interpreted, and then it works on the cluster. So let's take this approach now. If you have a large set of commands that you want to run, this may not be the right thing. You'll put all of them as one program, like how you design your Java programs, right? So you will have a design there and things like that as the program gets more complex. So for simple thing like this, where your DAG is simple and what you're doing with that is simple, and after all, what you're doing now is just a toy program. We'll just run a Spark shell. So that will start the Spark shell, and that will uh, give you access to the cluster. So when you start a Spark shell, what it gives you is, within the Spark shell, in the memory, you'll have something called Spark context. And Spark context is your entry point to interact with the cluster. So it will give you a starting point for whatever you do on the cluster. So see. So as you can see, this has created uh, Spark Context Web UI is available at this. So I'll not be able to reach this because I have not enabled the firewall access on the cluster. As you know, this machine is sitting on the Google Cloud, right? You can do this one of these days. So if you want to see how your job is progressing, you can actually go to the URL and see what your job is doing. And so Spark Context also keeps information on, what's the cluster operating system or cluster resource manager that you have here, and basically what you have is Spark based on Yarn, and this is the application ID. This is the usual Hadoop application ID, Yarn application ID. So when you run a process on a Hadoop cluster, it gives you an application ID. So with this application ID, you'll be able to extract logs from the run, and then you can also track what's happening with this. So that's what this is about. So you basically have an interactive shell here, like how you have a Python interpreter shell. This is also, so you basically have a Spark, Scala REPL. REPL is just that interactive shell, and it has Spark context included in the in, in the stack, and you will be able to interact with the cluster. So as I said, Spark context is your starting point, and Spark context has methods like text file, and I'm giving this parameter as so let's say should be that. So this is for reading the file that we actually put there. So when I do this, it actually came right away. It did not do, in fact, nothing happened on that, on the cluster. It did not read anything. The RDD was actually not constructed because, as I said, this is it just records this information. It says, it just checks whether the file is available or not, and then probably it doesn't even do that. What it's doing is, take this file and use the Spark context to actually look at that file and create a variable called lines. So when it actually is, when this is realized, what happens is lines will be the RDD, and think of that as a list where each item in the list is a line coming from this file. Okay, and I'll create another RDD from this one. So when I do this, what you're doing is one of those two actions that I mentioned on the PPT. So this is a map. So it takes the lines RDD and defines a map. The map is the taken element, and split that with comma as the delimiter. So if you remember, we had comma as the delimiter for that file, right? You see that. So the file had comma as the delimiter. So each line will be an element in the RDD. So the second this map, what this map did is it took a line and it split that up, and and made an array out of that. So now each element in parsed lines will be an array of items like this. So let's actually do one more thing. If you say lines dot take one, so what it does is it just prints. Oh, something happened. So create proxy. Let me see what's going on here. Maybe it needed. Okay, so I had missed a slash here. So lines dot take one. So this is your line, right? I mean, the first, each element is actually a whole line from that file, and I need to redo. So when I say this, it's using this it runs a map. It takes each line, splits them up by comma, and then have an array as an element of uh, as elements of the RDD. So each element in the RDD is an array in that case. If I say first lines dot take one, so this is just taking the first element there. So as you can see, the difference uh, between this and this is here the element is just this whole line. Here the element is this array. Okay, somebody had a question. Is it Savia?
Yeah, Kumar, we splitted that, right?
Yeah.
Lines.
Yeah.
In the past line take one, I am expecting only the date first.
Lines is an what is lines basically? Lines is an RDD. That's this whole set, right? And
Sorry.
and the first element of this set is this whole thing.
Oh, okay.
So each line is an element. That's what I mean. So
Yeah, Kumar, got it.
if I say lines dot take two, okay, so it got two of these. So that's the second one, right? So 2694, yeah. So that's the second one.
So when you say take two, it will take two lines, right?
Two lines, yeah. So it just
Not the second line.
yeah.
Oh, okay.
So I took that line, and when I did a split, what I did is I took that line and made instead of each line, I'll have an array of values from that line as my second RDD. Okay, so well, look at this one. The first RDD lines is this. Like each element will look like that, right? It's just a string.
Yeah.
The second RDD parser lines dot take, where I did a split. Each element within the RDD is actually an array again. So that's an array, right? So what you have inside of this array is this line. What you have inside of this array is one more array. Okay. So that's one thing. And so now what I'm doing is I'm creating one more. I'm doing one more transformation. So what I'll do is from this array, from parser lines array, I will take I'm making key value pairs basically. So this is the key. That's the value. Now, if you look at it, all these are seen as strings. It doesn't know which one is a number, which one is a floating point number, and which one is a string. So what I'm doing here is I take the third column. So you're looking at index starting from 0. So you're looking at, so that is 1, that is 2, that is 3, that is 4. I'm sorry, that is 0, 1, 2, 3, right? So this column that represents the portfolio, so I'm taking that as the key, and so that is 4, that is 5. So the fifth column, I'm converting that to float. I'm putting that as value. So I am creating key value pairs.
I think it is sixth column, right, Kumar? Fifth column is 0.
Well, the index starts from 0. So 0, 1, 2, that is 3, 4, 5.
Oh, okay.
Right. So So if I say map dot one, so I got the portfolio value and that number, and it also gives you the type. It says the key is of string type and the value is of type float. Right? So that's another thing that I did, and now I'll do some action on this. Now what this did is on the map past lines data structure, which comprises of key value pairs like this. I did a reduce by key, which means, you know, this is like your group by operation on a SQL table, uh, on a RDBMS table. So take key value pairs. I mean, take for each key, take two values. This is how you do. You actually reduce two given things. Take the values and add them up. So that means if it sees two neighbors with the same key, it actually adds the values up and makes them as one. So that's the individual. That's the operation with which it reduces the it reduces this whole thing. So as you can see,
But here,
this says shuffle RDD. So it shuffles the RDD, collects them by the key, and then between every neighbor, with the same key, it does this operation. And at the end, you'll have only one record per key.
but here, Kumar, A and B are different data types, right? How it adds?
No. These are not different types. Like, think of that as neighbors. With this, it's working on the values. So this is a rule for reducing two neighboring two values. That come from neighbors. Like, let's say you have. So this should be something like this. Let me write it here. So the A and B that you're seeing is this. Like, you know that you are doing a reduce by key. So you don't have to mention this is not the key. It's not
Okay.
value. So what it's doing is this. So if you have K1, let's say K1 V1 and K1 V2. So it's the same key, right? So what you're saying is take V1, V2 and reduce that to V1
Okay.
plus V2. So what it does is you take these two and then make.
So where did we mention about the key here, Kumar, in that syntax?
Make V1 1 second. V1 plus V2. Actually, that is implicit. So what you're doing is reduce by key. That method itself takes all the elements in the RDD, all the key value pairs. It sorts by key, and once it sorts by key, you know what it knows what the keys are, and all that it needs to reduce is just the values. You don't have to. You're not sorting by key for a specific key, right? You're sorting by key for all the keys. So it doesn't have to know each key.
But you said the key is same, right? K1, K1.
Well, if you.
So what is this K1 here in the syntax?
Okay, so let's actually look at this. This file, these are the keys we are looking at, right? Portfolio 4 in this case. So if you
Okay.
scroll down, you'll probably see other portfolios. 10. This is the value, right? I mean, sorry, this is the value. The last column is the value,
Correct.
right? So actually, let me
Yeah.
quickly do this. Yeah.
Oh, okay.
So when it sorts, when it sorts all of these by key, what happens? You will have portfolio one is what you will see at the beginning. All portfolio one entries, and then portfolio two entries come later. Portfolio three entries go after that, right? And
Yeah.
this is a rule for reducing elements with the same key. All that you need to provide is how the values get reduced, values get aggregated.
Okay.
You see the
So
point?
in this case, the key is portfolio one, and it will add all these relative float values.
Right, and it does that for all the portfolios.
Oh, okay.
So that's why you don't have to specify a portfolio in this,
Got
right?
it, Kumar. Yeah.
Because it has to scan through all the portfolios and do this for values with the same key. Okay, so once that is done, so if I say parse lines, okay, group by portfolio, that's the RDD that I made just now. So if I say take 5, okay, so you see portfolio 2, it reduced everything for portfolio 2, reduced everything for portfolio 8. It's not in the order that you would want. You could do an order by if you want, but I think that's okay. So that's another portfolio, that's another portfolio. It just added up the numbers. And one more thing you can do is past portfolio. Yeah. So this collect operation, brings everything to the driver process, and how do I? Okay. Yeah, this is scalar syntax. So for each, I'll say so that's the set of aggregated values. Right. So
There is some minus value also here, right?
yeah. I
Looks like
mean,
it.
it has the actual values are negatives as well.
Oh.
Uh,
Yeah, yeah. Okay. Got it, Kumar.
negatives, yeah. So that's what this is. So what we did now is we created an RDD. We ran some maps. We ran some actions as well. So there's some transformations and actions. So this basically is an action. We are actually bringing the results to the driver program, and for each you are doing this. You have to be very careful when you run a collect method on it, because if you have a very large RDD, your collect brings everything to the driver, and if your local machine where you're running this doesn't have enough memory, it can crash. So you have to make sure that you know what you're doing when you run collect. I guess I think we can just stop right there. I think we overshot our time. And
Kumar, if you have 1 minute, I'll ask last question.
sure, yeah.
So this operation, right? If it is a 4 MB, I can do a simple Java program. I can get this count, right? Why we are going with this Spark? No?
Well, with a simple Java program, you can do
I
this.
can get all, yeah.
Well, this is supposed to be scalable, right? So let us say you have 1 terabyte of data with this.
Okay.
So your Java program, you'll run out of heap space, and you'll not have a machine with 1 terabyte memory. You'll probably have a machine with 1 terabyte memory. I think that's possible nowadays. But then it will be a single process. You will not be able to parallelize, and you will not know how long it's going to take.
Yeah. Okay.
So this is just a toy program, right? You can of course accomplish this with any simple Python or Java programs. So this is just a demo of what you can do. Just scale this up, and that gives you. So, but this is RDD is the basic core API. You also can work with the large data sets using SQL kind of operations. You can do joins and things like that. So you can treat your data as tables. So that's another API within Spark that you can look at.
Okay.
And
So, for example, if I load 10 GB of data for same file,
yeah,
I run the same commands, it will give me the result, right? I don't bother
yeah,
about where
yeah,
the data is spread across the nodes.
right. So if this
Okay.
data was just 5 MB, if this was 500 gig, it will run the same way. There will not be any changes.
There is no difference in the syntaxes and all, right?
Nothing. Yeah.
Okay. Okay, Kumar.
So scalability is the key in this case.
Okay.
Okay, I guess we are done. Any other questions by anyone?
Can you share these files, Kumar? I just do the practice. I don't know
Yeah,
how
yeah,
I get
sure,
from your
sure.
Google
Yeah,
Drive.
I'll email this out.
Okay.
So now that I'm done, I'll delete the cluster. So that will stop the billing.
Maybe from future we can use my account too, Kumar. I have some $380 of credit, I think, for
Yeah,
our
I mean,
sessions.
that's okay. I mean, like I just opened something yesterday, so this is also
Okay.
a demo version, a trial version. Basically, this should be fine.
So they'll have a track of how much time you are using, I guess, right?
Yeah.
Yeah. You're billed according to what resources you use and for how much time.
So if it crosses